received your assignment, and I am very proud of your great work. Thank you so much. I really appreciate your work. You made me very proud. All right. Today we're going to continue solving a non-right triangles. So we have a triangle that's obtuse or acute, when there is no right triangle, how can we solve those triangles? How can we find the missing sides and angles? Actually, we are not going to use SOHCAHTOA anymore. In SOHCAHTOA only in a right triangle. We're going to use either sine law or cosine law. So those are the laws that we're going to use when we want to solve a triangle that's not right. Okay, so when to use sine law and when to use cosine law? We use sine law in these two cases. One, if we have two sides and an angle that is not included. So this is the first case. If we know these two sides, any two sides in the triangle, and the angle that's not between them. If I have this angle, I cannot use sine law. This is the first case. The second case, if we have two angles and one side. So this is the other case. If we have two angles, let's say we know this angle and any of these three sides, we use sine law. Okay, so when we use cosine law, if we know two sides and an included angle, so in case we have two sides and angle between them, we use cosine law. So this is the first one. And the second case, when we know three sides. If we know the three sides of the triangle and we want to find the angles, we use cosine law. Today we are going to learn sine law, and starting Monday we're going to learn cosine law. Cosine law may take like 2 days. Sine law, we are going to do it today. So what is sine law? We have a triangle A, B, C. Those are the angles. The side that's opposite to angle A is small a. The length of this side is small a. The length of this side is small c. The length of this side is small b. We can say that A over sine A equals B over sine B equals C over sine C. This is the law. And also if we flip, so we make the angles and the sines on the top, it will be also the same. Sine A over the length of side A equals sine B over B equal sine C over C. Okay, this is the law, the sine law. I'm not going to prove it. The proof is in the book if you want to see it, but show you how to use it because this is my concern. So I will give you some examples. Let us say we have this triangle. This is KPL. This angle is 66 degrees. This angle is 52 degrees. This side is 2.5 centimeter or 2.5 meter. So when we look at this and we need to solve this triangle, first thing I can get this angle because this angle will be 180. Take away 52 plus 66. So I can find out what this angle equals, even without using sine law or cosine law or anything. So 180 minus, open bracket, 52 plus 66, close bracket, hit enter. So this angle is 62 degrees. Okay, now where we need to find these two sides. Again, this is not a right triangle. I don't see any right angle, so I cannot use SOHCAHTOA. I have two angles on one side, so this is one of the conditions when we can use sine law. So I would say I want to find this length. This is small l, this is small k, this is small p. So I can say that L over sine L equal 2.5, which is k. Let me write it this way, equal k, small k over sine 62 equal small p over sine 52. Then we substitute with the information we know. So L over sine 66 degrees equal k, which is 2.5 over sine the angle that's opposite to it, so 62 degrees. Now what I need to do is isolate L, so I will multiply this everything by sine 66 degrees. So when I multiply this side by sine 66 degrees, it will cancel out, and in the other side we're going to have 2.5 sine 66 degrees over sine 62 degrees. Now I can use my calculator. 2.5 times sine 66 close bracket, then divide by sine 62 and hit enter. So you will get the length of this side, which will be 2.5866, so we can say 2.57. Okay, we know that this side now is 2.5 Then I will apply the sine law again, so I can use these two ratios. So k, which is 2.5 over sine 62, this will equal p, which is missing and I need to find it, over sine 52. Again, I want to isolate p, so I can say that p will equal, I will multiply everything by the denominator here, sine 52, so they cancel out. So that will be 2.5 sine 52 degrees divided by sine 62 degrees. Then I will go to the calculator and I will do the calculation. 2.5 times sine 52 divided by sine 62, and close the bracket and hit enter. We will find that the length of side B, P, equals 2.23. So now we know that this is 2.23. And we have solved the triangle. We found everything we need to find. Okay? I want to give you another example. So this example says we have triangle TUV. This is 5.8. This is 11.1. This is 31 degrees. So I want to know if I can use, this is not a right triangle, so I'm either using sine law or cosine law. So I will see what I have. I have two sides, an angle that's not in between, so it is sine law. So I'm going to write sine laws, the thing. So sine 31 degrees over the opposite side equal sine u over, I don't know u, so I can use sine v now. Sine v over 11.1. Then I will solve for sine v. So sine v, I will multiply everything by 11.1. So 11.1 sine 31 degrees over 5.8. That's sine of angle v. I will use the calculator. So 11.1 times sine 31 divided by 5.8 equals oh, I did something wrong. 11.1. Oh, I did a mistake, sorry. So 11.1 times sine 31, close bracket, then divide the answer by 5.8. You will get, yes, you will get 0.98567. So V equal sine minus 1, this value 0.98567. So inverse sine 0.98567. So the measurement of angle B, so measurement of angle B equals 80.3. So this angle is 80.3. Now we found this now. 80.3. Then we can use U equals, measurement of angle U equals 180. Take away 80.3 plus 31, and this will be 180 minus, open bracket, 80.3 plus 31, close bracket, hit enter. So this angle is 68.7. Okay, so now I have to end, and I will post everything. Bye.